Okay, so we're going to go over semester review number 11.
Wait, she can hear us.
Questions? I hope so.
Hi, Sarah.
Okay,
See us?
she can't see us. She can only see the board.
Sarah.
Okay, so anyone get problem number 1?
I sort of factored it.
Okay. What you're going to want to do, I sent you a hint.
I got one.
Okay, so I sent you a hint, and the hint was to group the terms that have x's and y's, and then the other 3 terms.
I
Okay,
didn't
so
know
let's
these
group
were-
these. X squared plus 4xy plus 4y squared minus a squared minus 2a minus 1. Okay? If we look at the first 3 terms, can we factor those?
Yeah.
Yeah, how do we factor that?
Isn't it x plus 2y squared?
Nice. X plus 2y quantity squared. Okay? I don't like all these negative signs here, so I'm going to factor out a negative 1 from the last group. Right, so I'm going to rewrite this as minus a squared plus 2a plus 1. Is that okay? Factor out negative 1 from all 3 terms. And then what can we do with those last 3 terms in the parentheses? How can I factor that?
A plus 1.
Yeah, a plus 1 quantity squared. Okay, what do you notice about that when I have x plus 2y quantity squared minus a plus 1 quantity squared? It's a difference of squares, our old friend that I told you we were going to see over and over and over this year. There it is again, difference of squares, and I can factor that as x plus 2y plus, Dylan, a plus 1 times x plus 2y minus a plus 1. Okay, and if you look on the answer in the back, I'm sure it's from this. It's x plus 2y plus a plus 1 times x plus 2y minus a minus 1. Okay? So that was a good way to review
I didn't delete it.
factoring, difference of
Sure
squares.
I did.
Okay, but that didn't help so much, right?
Well,
Okay,
I factored
next
it.
one. I want to simplify a 5th root. Okay, this problem is going to be a good review for us to remember how you rationalize denominators when it's not a square root. Okay, so first step, what do you suggest we do? I've got a 5th root of a quotient.
Hashtag super.
Do fifth root of the denominator.
Hashtag super.
Yeah. Yes, so rewrite this as the 5th root of x over the 5th root of 9y cubed. Okay? The problem here is we have a 5th root in the denominator, and we cannot have a radical in the denominator. Yeah, Julia.
This probably isn't right, but I multiplied it like 5 times by the fifth root, like you know how when you
This
get a radical,
Yeah.
you multiply by like the same thing, but I did like 5 times.
Okay, Julia's idea is great. We need 5 of each of the factors in order to get the 5th root out of the denominator. Okay, but what Julia did, using this thing 4 more times, is going to give us bigger quantities than we really need.
Yeah,
So
it's
we
not
can
fair.
be a little bit more clever. Okay, and I'm going to start this so that we can use Julia's concept, but make it a little easier for us.
Why don't we just do
I'm going to rewrite 9 as 3 squared.
wait. How about this?
Is that okay?
Wait. How about this? We do 9y to the third, to the power of 1/5. Oh, and then there's.
No, taking the 5th root will change this. It's not an equation. I can't raise both sides
No,
of
to
the
the-
power.
No.
Oh, write it as 9 to the 1/5, y to the 3/5.
That's what I did. I didn't know.
No.
Okay. What we need, let's think about what Julia said. We need 5 3's and 5 y's under this 5th root. Then we could undo this, right?
Wait, what does simplifying mean in this situation?
Simplify means get rid of the radical in the denominator.
Oh.
Okay? So how can I get 5 of each of the factors? Right?
Multiply it by
Yeah.
5.
What would I multiply this by?
2.
Oh, you could do like 3 times 3 to the third.
3 to the third.
And y
Nice.
to the second.
Very nice.
Yeah,
Okay. Now, can I just put it like that? Can I just put that?
Why did you do
Okay. Because in the end, we want 5 3's. So we have 2 3's here. This will give us 3 more 3's under the 5th root. Now, is that okay, what we just did?
You need to
If you
multiply
do
it by
the
the
top.
I need the numerator to be the same thing, right? So I need to have the numerator be the 5th root of 3 cubed y squared, because this is the finding form of 1. And that is the easiest form of 1. That's going to help us rationalize the denominator. Okay, so what happens in the denominator now?
It's
Right, we have the 5th root of
the
3 to the 5th, y to the 5th. That was the whole idea, right? So now what happens to the denominator?
Like the radical comes out.
Yeah, it's gone, right? It becomes
3y.
3y. Okay, so now you simplify this. We got rid of the radical. The numerator, I'm going to have the 5th root of 3 cubed, which is 27 times x times y squared. And there's nothing I can do with that. So this is our answer. Okay? But the idea here is to undo a 5th root, you need 5 equal factors. Right? What if we're a 4th root? We would need how many equal factors? 4 equal factors. Okay, so you're really comfortable when it's a square root, no problem, right? Like what if I asked you to rationalize this? What would you do? Simplify.
Multiply the top, bottom is.
Yeah, rad 7 over rad 7, right? Why does that work? Because this is really a square root, and you need 2 7s. Okay, so we're generalizing that idea. Okay, so really nice thinking on that. Okay, this one's really tedious. Anyone get it? Okay, so this problem is going to help us review composition
Okay.
and simplifying complex fractions. Write small.
Kill me now.
Okay? Alright, here we go. We're going to start. Well, first we'll work with f of g of x minus 1. Okay, where should we start with that?
Substitute x minus 1 in for x in equation g of x.
Perfect. Okay, so start on the inside, work your way out. So we want to find out what g of x minus 1 is. So let's do what Matt said. Substitute x minus 1 in here. So we're going to have x minus 1 plus 1 over x minus 1 minus 1.
What?
We'll simplify that.
What?
This is g of x minus 1. We're just putting x minus 1 in for x.
So it's just -1.
Yeah, the numerator becomes x.
I thought they crossed out.
Wait,
Oh, you have to
wait.
No, we can't put it.
X is x over x minus 2. X is x plus x. When we're
I'm
reading
putting x minus 1 in for x in the g of x function.
Yeah, so shouldn't it be x plus 1, x minus, x plus 1 plus 1?
No, I'm putting x minus 1 in
For what?
for x. G of x minus 1, Dylan. I'm taking x minus 1, putting it in for x here. X minus
Okay.
1 plus 1. I'm putting x minus 1 in for x down here.
Okay.
X minus 1 minus 1. Okay? That's g of x minus 1. What's the next thing we need to do?
You do f of x
Yeah.
over x.
So f of g of x minus 1 is f of x over x minus 2. That's the next step. Okay, let's do it. Everywhere I see an x in f of x, I'm going to put in x over x minus 2. So I'm going to have x over x minus 2 minus 1 over x over x minus 2 plus 1. Okay?
Ooh.
All right, to simplify the complex fraction, okay, there are 2 methods. One is we could simplify the numerator, simplify the denominator, and then divide fractions by taking the reciprocal of the denominator and multiplying. The easier way is to multiply the numerator and denominator by the least common denominator of all 4 terms.
Wait, what if you change the negative? What if you change the 1s to x minus 2 over x?
You could. That's the first method.
Oh, okay.
That would be the first method. But the second method is actually easier. The least common denominator of these fractions is x minus 2. You guys agree?
Car.
Yeah. Dylan.
What?
So, I want to multiply these by the least common denominator. Both the numerator and the denominator. This is fine, right? This is a funny form of 1. Alright, when I multiply this through in the numerator, when I multiply x times x over x minus 2 times x minus 2, what do I get? The first term. When I distribute this in, Dylan, focus. What do we get here when we multiply this?
You get x squared minus.
These cancel,
Oh.
right? X over x minus 2 times x minus 2. The denominator
X.
cancel becomes x.
So x
Minus.
x plus 2, right?
Yes. Yes. Minus, I'm going to write it this way. You already distributed it.
Wait, I got confused. Why?
I'm multiplying this whole complex fraction by the least common denominator over the least common denominator because that's going to clear the fractions.
How did you get? Why is it x squared?
Because this is in the, I canceled this factor out. Here, let me show you. This is x over x minus 2 times x minus 2 over 1 minus 1 times x minus 2 over 1. Then these cancel out.
Okay.
Okay? Everybody good? All right, how about the denominator? What do we get in the denominator when we multiply this through? So x over x minus 2 times x minus 2 over 1.
X plus x minus 2.
Yeah, x plus x minus 2. Very good. And then let's keep simplifying this. So this is going to give us
2 on top.
x minus x plus 2, which is 2 over,
2x minus 2.
yeah, so 2 over 2x minus 2,
Which would
And-
then be 1 over x minus 1.
which is 1 over x minus 1. Okay, so this is only half the problem. This is f of g of x minus 1. Okay? We have to do that whole thing again. Bless you. Okay.
Or
This is
We call it
1 over x minus 1. Okay, so let's try it again. We're going to do g of f of x minus 1. Where do we start?
f of x.
F of x minus 1. Okay, let's do it. F of x minus 1. Okay, I have to get my sheet up because I can't see it anymore. Okay, f of x minus 1 is going to be
X minus 1 over 1.
x minus 1 minus 1 over x minus 1 plus 1. Okay, so this is going to be x minus 2 over x. Dylan, try to focus. X minus 2 over x. Now we want to find g of f of x minus 1. So that's g of x minus 2 over x.
Wait, we have already known it was gonna be x minus 2 over x because
Yes, it's the
Oh
reciprocal.
god, did we just? Oh
Yeah.
god.
Okay, g of x minus 2 over x. Good thinking. Okay, so this is going to be, what's g of x minus 2 over x? So it's x minus 2 over x plus 1 over x minus 2 over x minus 1. Okay, to simplify that,
Multiplied by x.
yes, multiply that by x over 1 over x over 1. Alright, so Natalie, this first term, when you multiply x minus 2 over x times x, you get
wait, x minus 2
Good.
plus x.
nice. X minus 2 plus x, good. And then the denominator becomes, these x's cancel out. So x minus 2 minus x. Okay, so this becomes what? 2x minus 2 over negative 2. Alright, and then we can cancel out the 2's.
So you get negative x plus 1.
Negative x plus 1, which is 1 minus x. Okay, everybody good? Alright, but that's not the end of this problem. So this problem really wants us to find f of g of x minus 1 minus g of f of x minus 1. Okay, so what were these? F of g of x minus 1 was the first one we found.
1 over x minus 1.
1 over x minus 1. And this one is
X 1 minus x.
1 minus x. Alright, how are we going to simplify that? This would be better, actually, I think, to leave it as, flip this around, right?
Doesn't really matter. What?
It'd be nice if this were an x minus 1, wouldn't it?
It doesn't really matter.
Okay, what
Wait,
should we
x
do?
minus 1.
You can't
You can't-
turn it into x minus
I could change the sign by factoring out the negative 1. I could do it as plus.
Oh wait, no, that's wrong. That's not wrong. That's
What's
not,
wrong?
That's wrong. You can't say it's minus 1 minus x because that would give you negative 1.
Can I distribute the negative?
Yeah, but it's not negative 1. It's plus 1 that we got.
No, we got x 1 minus
Oh,
x.
okay.
Can I do that? Plus x minus 1? 1 over x minus 1 plus x minus 1 over 1. Okay, how am I going to combine those fractions? How am I going to add them? Yeah, multiply by x minus 1 over x minus 1. Okay, so that's going to give us 1 over x minus 1 plus x squared minus 2x plus 1 over x minus 1. Finally, we can add these fractions. X squared minus 2x plus 2 over x minus 1. Hooray! Okay, I'm going to start the recording.
Something happened.
Stop.